Hi, my name's Timothy Garton, and I'm here today to present More Than Touch, Understanding How People Use Skin as an Input Surface for Mobile Computing. This was originally presented at the CHI 2014 One-of-a-Kind Conference in the Watches and Small Devices session. A quick introduction is define the problem space, which is utilizing skin as an input device. And specifically, this is going to be performed within the mobile computing field. And the reason why it's limited to the mobile computing field is because the miniaturization of different devices, such as smartwatches and head-mounted displays, providing little to no surface area, so all traditional input methods can no longer be performed. And the reason why skin is being considered is because of the qualities provided by skin. First off, it's a input surface that is large and conveniently accessed. The skin is also flexible and stretchable. That allows us to define multiple different input modalities. And it's also personal and emotional based on the physiological properties and the location of where the input is actually entered. So what we're going to look at today is the goals of their study. The first goal was, what are the characteristics of skin-specific input modalities, and what modalities do people most often use? The second goal was to find what kind of gestures the users perform on their skin, and the third task was to find the preferred locations on the upper limb for multimodal skin input. A quick summary of the study is we defined 8 different modalities. For each of these modalities, we had a restricted input area to the upper limb. 6 areas were defined on the upper limb where the modalities would be input. We also limited the study to have no sensor technology for the input and no system output. The sensors were to prevent issues with user acceptance and to focus our study on the basic input on bare skin. The no system output was to prevent biasing by specific forms of output and the location where that output may occur. And our study has 3 tasks. Our first task was to present the user with 40 different reference and provide them with the 8 different modalities. And then they were asked to invent a gesture and perform them anywhere on the skin of the upper arm. The results were then recorded. The second task was performing the 8 modalities in general. And what they did is they had all 8 modalities performed on each of the 6 locations of the upper limb, and for each of these combinations they were recording on a 5-point Likert scale what was the ease of the performance and what was the comfort of use of the performance. And the third task was a derived list of non-gestural interactions with a mobile device, such as keyboards or different touch screens. And it was a survey on where on the upper limbs they would most likely input the similar input if they were provided an area on the skin. For the participant are listed here. We have 22 voluntary subjects, half male, half female. The most important thing about this is they are pre-exposed. They're pre-exposed to computing devices, and 17 actually owned a touchscreen device. So let's look at the results first for task 1. 3 different areas were investigated. One was standard commands that could be compared in previous studies. The second area of interest was variations of those standard commands. And the final area of interest was the emotions. Most standard commands looked at use of just conventional multi-touch. This is most likely because of the number of participants that have touchscreen devices already that they are familiar with it. However, things like help and reject call, which require some sort of special input, they were very specific and needed a skin-specific gesture to show the importance. For variations, the main topic of interest was the importance of the variation. Was it a forced close or a hide close? In the situation of the forced close, you see that it's very skin-specific. In the situation of a hide close, where it's not as permanent, it's not a skin-specific, but rather a multi-touch. And in the situation of emotions almost always required some sort of skin-specific input inside the gestures. And in a similar pattern here, you'll see that the majority of input percentage of the gestures were performed with multi-touch. That's based off of the larger percentage of the standard commands, which were most often using multi-touch. What's interesting here to see is that the percentage of gestures follows the same pattern as the perceived ease and perceived comfort. They're in the same pattern and order. The one place that is unique in that is scratching. Although it's perceived as easily performed, the comfort is not perceived as acceptable. So therefore, scratching scored lower on the perceived comfort. The second task that we looked at was where these modalities are actually performed. And 50% of the time, you'll see that the forearm was the area that was most likely used. Upper arms and elbows were not convenient and did not provide many of the physiological properties, and therefore were the lowest scores. And specifically in the palm and back of hand, those were used specifically whenever privacy or precision was needed. And in task 3, the areas of interest here dealt with the precision and the ease of use and the ready to be used of the handwriting of the number pad. What they were looking at was quite often if the palm was used, that was a situation where the concept was often performed close to the hand. And the reason for it being close to the hand is so that it's readily available. It's also whenever it needed precision was needed for accurate input. And as we talked about with the palm versus forearm and hand, we see that in the sketching, which usually sketching was considered to be most important was privacy of your sketch. And if it was performed on the inside, 41% of private sketchings were done on the inside of the palm. So what are the implications of this study? What we have is we have now defined gestures and input modalities that are most likely could be used for design of input devices. We've also defined areas of the location where to apply sensors and devices for input based on the different gestures. We've also can lead to define the different input sensors and what types of sensors they need. Are they rotating? Are they force? Are they pressure? Or what types of sensors need to be designed to collect the types of input? And also what types of output devices can be able to show what the results are. So there were some limitations to the experiment. This experiment was performed inside a controlled environment. There were no weather implications. It was done during the summertime. Therefore, most participants were wearing short sleeves. Since this study looked at just the upper limb, weather conditions could impact the response. If there's inability to access the skin, you may be limited to just the palm or just the forearm, and maybe not the upper arm, which was one of the input locations. The other thing is the scene. All of their experiments were performed in a seated and a comfortable setting of a single user. There are various conditions that could impact this scene, such as running, standing, large populations, or just being out in public. Any of these could impact the method for how a user would actually interact with their skin, or how to prevent even false inputs from skin. So after this study, we do still have a large area of places where they could consider future work. The first empirical studies look at what is the actual performance of these input modalities. And other studies could define, are there additional emotions or interpersonal commands that could expand the list of gestures. And a final study could be, what are the cultural effects on people communicating through these gestures and through devices. Future work could also involve the sensors, which is how do we actually integrate these into the environment. And the last thing that they could investigate is, what are the different implementation of proposed gestures? How do they actually collect what the gesture was and perform a action on the electronic device? With that, that concludes the presentation. I now open the floor to any questions. If there's no questions, I'd now like to acknowledge the people that helped to perform and fund this research topic. The work was partially funded by the Cluster of Excellence on Multimodal Computing and Interaction of the German Federal Excellence Initiative. We'd also like to thank the anonymous participants. And we'd also like to thank Simon Alberding, who provided input into our testing practices. Thank you and have a good day.